If you look at this one for me, the first thing I'd like you to check, and if you don't have your calculator out, you can get it out to help you, is does it have a GCF? Can you check for me, please? Okay, what do you think? Does it? No, I don't think so, because 49, your only factors would be like 1, 49, 7, 7. Am I missing something? Maybe. But those are not the same factors as you have for 28 and 4. So no. Okay, now we move on to the next question, which is how many terms does it have? 3. And so when you have 3 terms, you do what?
X game.
Yeah, you do the X game. And you can, okay? So just know that, yes, you can do the X game. I know some of you actually tried this one yesterday. When you try and play the X game and you multiply 49 times 4, you get this really lovely number of 196, which I don't know about you, but I'm not super familiar with all the factors of 196. And so you could do it like this. It's just going to be kind of annoying. But you can, of course, factor like that, right? And then do grouping and split and all of that. It'll work. It'll just take you a little bit longer. You could also recognize what you have for the A term and the C term, which is what? Squares, yes. So obviously this is a perfect square trinomial, but let's talk about why. Because if you're coming from Algebra 2, and to be honest with you, this is not something we super explicitly teach. We kind of talk about it, and then we just kind of move on. Because you can always do the X game and factor like that. But what is the square here? What squared is 49? 7. We're going to go ahead and put 7x because the first term is 49x squared. Okay, and then look at your last term because that's also a square. What's squared to get 4? 2, yeah, and we'll say 2y since that's 4y squared. When it's a perfect square trinomial, you should have squares, obviously, for A and C. You should also see in the middle that this middle term is 2 times 7x times 2y. So if you, no, that's the wrong thing. Okay. If you take your A and your C, well, I guess they're A and B, sorry. If you take those two things, 7x and 2y, and I multiply them together, I get 14xy, and then I double it, and I get 28. Laws is excited today. Yeah, so that would be how you could check and see, okay, is this a perfect square trinomial, yes or no? I have squares at the beginning and end. My middle term is double of those two, A and B. All right, so yes, it is. You could play the X game. It's going to take longer. So you can also just look at this and know, if I pay attention to the sign in the middle, this becomes, I'll zoom out, hold on. Okay, this becomes 7x plus 2y squared. It's this pattern that you see right here is what this example is. Whatever the sign is for the middle term would be what your sign is in the parentheses. If you are like kind of sure but not quite sure, you could always check your work. Can you talk to your table? How do you check your work? Yeah, if you multiply this back out. So if I want to check my work, I do this, right? So I would say, okay, I think the factors are 7x plus 2y squared, so that means there's 2 of them, and I would just then have to FOIL it back out and see, does it match my original? Spoiler, obviously, yes, this one does. Because you end up getting 14xy in the middle, which then adds to 28xy, okay? So if you're ever unsure in your factoring, FOIL it back out and see if you're right. Here on the bottom of the page, these are ones you're going to do on your own in a second. Difference of squares and difference in sum of cubes. A reminder that we have this acronym, SOAP, same, opposite, always positive, which helps you figure out the signs that go in between the terms, which I'll show you more in a second. If you have a negative exponent remaining in your expression, you are not done. So please make sure that the negative moves to the other side. So here's 2 examples for you. If I had something like this, where I just had like an x to the negative 5, I have to move it to the other side, the whole thing, okay? And it would become 1 over x to the positive 5. Another example for you, let's say I have like x to the 3rd and then y to the negative 2nd. Okay, this is an example where not both of these are negative. The only thing that has a negative power is the y, and so that's the only thing that moves down. And I know it's not a fraction right now, but guys, you can make it a fraction. So then it becomes x to the third over y to the positive second. Why doesn't the x to the third move? We'll do two little tiny examples here. If I have, for example, I don't know, pick a different letter, m to the 7th over m to the 3rd. I subtract these two lovelies, and I get m to the 4th. And it's on the top. If you were subtracting top minus the bottom, that's supposed to be a minus sign. It didn't do a very good job. If I'm subtracting the 7 minus the 3, then I need to make sure my answer goes to the top of the fraction. So if there was a bar here still, I would have to have it on the top. Okay, another example of how to make your life a little bit easier. If I have something like, we'll use x again, x to the 4th over x to the 15th. It's the same base. If you have the same base, you're not done. So when I have the same base in division, I need to subtract my exponents. You can subtract this, 4 minus 15, and get x to the negative 11th on the top of the fraction. But then you have to move it back to the bottom. Anyways, because it's negative, and we don't want a negative, it would be a little bit easier, and you can do this if you want, but I just cancel. So I see 4 on the top, 15 on the bottom, which means that these go away, and I take away the 4 from the bottom, leaving me with 11 in the bottom of the fraction in the denominator. I have to fill the empty spot with a 1. Okay? So yes, you can subtract and get a negative on top and then move it, or you can just cancel out. Okay, can you talk at your table about number 3? What do you think you should do first? Okay, what's the first letter in order of operations? P. Parentheses. So you have to deal with your parentheses, and that you need to, yes, distribute your exponent. So you should do this first. It's not registering. 4 times negative 3. Okay? I don't know when it's going to show up.